Data classification helps organizations identify and categorize sensitive information such as PII, financial data, intellectual property, or other confidential data. By classifying data, organizations can apply appropriate security controls and policies to protect it from unauthorized access or disclosures. In this video, I'll cover one of the Zscaler advanced data classification technique called Exact Data Match or EDM. Many organizations have custom data that needs to be secured. This sensitive data may not be covered by a predefined dictionary. Zscaler Exact Data Match provides organization precise control to find specific data values, protect PII, and reduce false positives. EDM uses a record from a structured data source, identify and correlate multiple tokens that matches predefined criteria. Once the data is indexed, only hashes over encrypted connections are sent to the Zscaler cloud. Zscaler EDM ensures that sensitive data is protected accurately and efficiently, minimizing the risk of data breaches and ensures compliance with data protection regulations. So let's see how EDM works. EDM index tool collects sensitive data that needs to be protected. This data typically comes from structured data sources like databases, spreadsheets, and other repositories that contains PII, financial data, or other confidential information. The tool creates an index of the data. This index represents the sensitive data that allows Zscaler to identify exact matches during the data inspection. Note that the sensitive data is hashed and encrypted to ensure that it remains secure. EDM template defines the specific type of sensitive data that needs to be matched. This includes defining the fields like first name, last name, social security, and the exact format that these fields follow. As you can see, that first name and last name data type is alphanumeric, city is multi-alphanumeric, whereas CCN is credit card number. In the template, each field from the source data is mapped to a corresponding field in the EDM template. This mapping ensures that the data is accurately represented in the index. The EDM template is added to the custom DLP dictionaries where you define the primary and secondary fields you want the dictionary to match against when scanning contents to count it as a valid match. You must select at least one primary field and not more than two. As shown here, I have selected social security as my primary field. To improve the accuracy, in addition to the primary field, the dictionary can match on multiple or even all secondary fields. I have selected first name and last name are my two secondary fields. The dictionary is referenced in the DLP engine, which is called by the EDM defined DLP policy. The policy rule defines the action taken when a match is found for the outbound traffic. Note that the data is inspected in real time against the EDM index. The template guides the inspection process, ensures that only the exact matches as defined by the index data trigger the DLP policies. So let's hop onto the portal and see EDM in action. So this is the inline EDM DLP policy that uses the engine. The action is set to block. The EDM dictionary that uses the social security as the primary field, first name, last name, and the two secondary fields, and we are matching on both. The EDM engine that uses this dictionary. So the two sample files that I'll use for this demo, the first one is the one that contains social security and the first name, last name. And the second sample file, if you notice, contains credit card, first name, last name, and a bunch of other data, but it's missing the social security, which is our primary field. So let's first upload the file with the credit card and the first name and last name. And as you would expect, that since it's missing the social security, which is a primary field, this post was successful. So if we upload the file that contains social security and both the secondary fields, and the action is set to block, so since the policy is matched in this case, this upload should be denied. As you could see, that this was the expected result because we have a policy match here. So if we go back to our dictionary and let's add a third secondary field, let's say city, and we'll continue to match on all secondary fields. Let's save and activate the change, and we'll go back and upload the same file again. But this time, since one of the three secondary fields is missing, this upload should not match the policy and should not be blocked. So you see that this post was successful as expected. Let's go back and check the logs, and you see that this is the user which violates the policy. The block policy is EDM. We use DLP test. SSL inspection is enabled. DLP engine dictionary, and this is the file that was blocked, 403 forbidden. This is the file when we had SSN as a primary field and first name, last name were the two secondary fields, and this upload was blocked. So to recap, we saw how Zscaler EDM works on a structured data using index tool and template, which indexes the sensitive data. We saw how DLP dictionary using the combination of primary and secondary fields integrate with DLP policy to secure confidential data that matters you the most. So hope you find the content presented in this video useful. If you have any questions, let me know. Thanks and have a great day.